Good afternoon, ladies and gentlemen. In today's presentation, we are going to discuss about how you are going to apply the visualization and symbolization teaching approach during your teaching of the two grade 11 mathematics topics earmarked for this research, which are equations, functions, and graphs. My name is Themba Monemo, and I'm a PhD research student at Rhodes University. I'll be your host for this presentation. Sorry. We're going to start our presentation by discussing what is visualization and what is symbolization in mathematics education. Starting with visualization. Visualization in brief is the process of creation, interpretation, and the use of pictures, images, diagrams in our minds on paper or with technological tools with the purpose of depicting and communicating information to advance understanding. And this definition was given by Zimmerman and Cunningham in 1991. Also in 1991, Toll and Thomas, in their investigation on the application of versatile thinking in algebra using technology, discovered that there exists a significant visual element in algebra, which they called the visual symbolic form or symbolic visualization, which was an addition to the Zimmerman and Cunningham's definition, which they regarded as the visual spatial mode or spatial visualization. So what actually was proposed by these two scholars was that the visualization definition given by Zimmerman and Cunningham was incomplete because it only discusses about the process of creation and the use of pictures, images, and diagrams in an individual's mind, and does not consider the process of creation of mathematical information in symbolic form, which is the symbolic visualization. So the definition of Zimmerman and Cunningham only refers to spatial visualization, whereas the symbolic visualization component is missing. So the two scholars gave an extension or broadened the definition of visualization to include symbolic visualization. In this extension, which is the visual symbolic mode or symbolic visualization, numbers, number patterns, symbols, mathematical formula drawn or written on paper may be pictured in one's mind in the same way as diagrams, pictures, or other visual components of mathematical information can in the visual spatial mode be pictured in the individual's mind. This discovery made me realize that the concept of visualization with its broader meaning has a far-reaching influence on how mathematics can easily be learned, and could be the reason why during my high school career, I could unknowingly applying it easily master mathematical concepts, including also the successful solving of various mathematical problems. Next, we discuss what symbolization is. Symbolization, on the other hand, is described as a process that involves the use of mathematical symbols to communicate, manipulate, and reflect upon abstract mathematical concepts. But let us move on now to the discussion of what is a visualization and symbolization teaching approach, which is the one that is the subject of our discussion. A visualization and symbolization teaching and learning approach is an approach that integrates visual reasoning, thinking strategies, and symbolization processes with analytic thinking strategies in the teaching and learning of mathematics and in the solving of mathematical problems produce a wide range of solutions that are either symbolic, algebraic, logically analytic, or graphical in nature. This approach is a multi-dimensional approach that relies on perception and visual insight, two important skills in mathematics education that students can use in the learning of mathematics and understanding of mathematical concepts and mathematical processes, including the devising of appropriate mathematical problem-solving strategies that they can use to solve various mathematical problems in the mathematics classroom. So in comparison to the traditional teaching approach, in terms of the components of each approach, the traditional teaching approach was found by researchers to predominantly employing analytic thinking strategies only, while with the visualization and symbolization approach, it also applies the analytic thinking strategies, and in addition to that, applies also visual reasoning, thinking strategies, and symbolization processes. So basically, when we compare the two, these are the components of the two approaches in comparison to one another. So that we will have the components of the visualization and symbolization teaching model as given by that flow diagram. So the visualization and symbolization teaching approach has got four components, which are it employs analytic thinking strategies, symbolization processes, symbolic visualization, and spatial visualization. So these are the four components that constitute the visualization and symbolization teaching approach. And next, let us look at examples of questions under quadratic equations, where analytic thinking, visual, spatial, visual, symbolic thinking strategies can be applied in solving problems in the mathematics classroom. Example one, we're going to look at the application of analytic thinking methods to solve X, this quadratic equation. So for the analytic thinking methods, there are actually three all in all. The first one, A, the solution by factorization using the analytic thinking approach. We have our quadratic equation. The first step, we multiply by a negative throughout to make it positive, so that this becomes 2x squared minus 11x plus 12 is equal to 0. And then with the analytic thinking approach factorization method, we factorize the quadratic equation by grouping. In other words, it involves the splitting of this negative 11x into two terms, so that at the end we have four terms that we group into pairs and factorize up until we finally get our answer at the end. So with this method, we take the first term and the last term, we multiply the two. 2x squared times 12, we get 24x squared. And then in the next step is we look for factors of 24x squared that when we add them, they give us the middle coefficient or the middle term. So the factors are 24x squared are negative 8x times negative 3x. Because what happens is if you take a negative 8x minus 3x, you get minus 11x, which is the middle term. So the factors are minus 8x minus 3x. And we replace this negative 11x with minus 8x minus 3x in the middle there, so that we have four terms. And then in the next step, we're going to factorize by grouping. In other words, the first two terms, we factorize them. And the last two terms, we also factorize them separately. Highest common factor here is 2x. Then to get 2x squared, you multiply with x, then minus 4, get minus 8x. Then the second two terms, the last two terms, sorry, the common factor is negative 3. Inside the bracket, you multiply with x. The sign changes. So minus 3, you multiply with minus 4 to get plus 12. And then we arrive at this step. And we can see x minus 4 is common. So we factor out that outside the bracket. And what is in the other bracket will be what remains, which is 2x minus 3 is equal to 0. Right, we have that x minus 4 times 2x minus 3 is equal to 0, which we then solve by equaling each bracket to 0 to obtain x is equal to 4 or 1,5. If you look at this factorization using analytic thinking approach, it involves the factorization by grouping and is a little bit longer. Because if we are going to count the number of steps that we take, this is not a step name. We start counting from, this is the 1, 2, 3, 4, 5. So we have 5 steps that we went through in solving this equation by factorization using analytic thinking. You are going to see that when we factorize using the visual symbolic thinking approach, it's much shorter and quicker, and you actually get the answer in a few. So here we have 5 steps, and this is one of the analytic thinking methods to solve the equation, which is A. Then the other methods, which is B and C, are by completing the square, and C using the quadratic formula. And all these 3 are under the analytic thinking methods. Let us look at B. Let us quickly look at that because we are all familiar with that. We have our quadratic equation. We multiply by negative throughout to make negative. And you know, with completing the square, we divide throughout by the coefficient of x squared. We get x squared minus 11 over 2x plus 6 is equal to 0. And then in the process of completing the square, we take the middle coefficient, minus 11 over 2, divided by 2 to get minus 11 over 4. Then we are going to put it in a bracket with x, so that we have x minus 11 over 4, bracket squared. And when you expand this, you are going to get x squared minus 11 over 2x. But you also have plus 11 over 4 squared, which is not in the previous expression. So what we do is when we write this expression, we have to subtract 11 over 4 squared. I hope and think everyone is familiar with this. In other words, sorry, when you expand these 2 squares, when you expand, you are going to get x squared minus 11 over 2x. And then there is a plus 6, which is equal to 0. And the next step, we take all the constant terms to the other side and simplify them. We'll get 25 over 16. So the x minus 11 over 4 squared is equal to 25 over 16. And then x minus 11 over 4 is equal to plus or minus the square root of 25 over 16. And then x will be equal to 11 over 4 plus or minus 5 over 4, which is that square root. And when we simplify that, we will get x is equal to 4 or 1,5, which is the same solution as the previous part A. A solution we determined by factorization. And then the last method under analytic thinking strategy is using the quadratic formula. What we do is we have the same equation, multiply it throughout by negative to make it positive. Then we identify our parameters A, B, and C. So A is equal to 2, B is negative 11, C is equal to 12. And then we quote our quadratic equation formula. And then what we are going to do is we are going to substitute these parameters in our quadratic equation formula, which we will then simplify like the square root. When you simplify these terms, negative 11 squared minus 4 times 2 times 12, you get 25. So it will be 11 plus or minus the square root of 25 over 2 times 2, which is 4. Then x will be equal to 11 plus or minus 5 over 4. And then the final answer, again, the same, x is equal to 4 or 1,5. So there are 3 methods under analytic thinking approach for solving the same equation. And then let us move on to the other method, the second one, which is using visual spatial thinking. We are going to look at example 2. If you look at example 2, the question has been restructured differently from example 1. In that it reads the distance s of a particle p from a starting position at t is equal to 0 is given by s is equal to negative 2t squared plus 11t minus 12, where s is in meters and t is in seconds. Determine graphically the values of t when s is equal to 0 by drawing a graph of s versus t for values of t from 0 to 5. This question or example is actually similar to example 1, in that we have just replaced ux with t, because if you remember example 1, it was the quadratic equation was minus 2x squared plus 11x minus 12 is equal to 0. So we, in this case, replacing t with for x. So basically we are looking at the same equation, only that the equation has been restructured differently. So they want us to determine graphically the values of t when s is equal to 0. When you put s is equal to 0, you will see that it becomes the quadratic equation that we solved in example 1. So we are using the visual spatial thinking approach or spatial visualization. So solution graphically using the visual spatial thinking approach. What we're going to do is we're going to draw a table, t values from 0 to 5. And then in the table, we are going to have the 3 terms, vertically minus 2t squared plus 11t minus 12. We're going to determine the value of each one of them when t is 0, 1, 2, and so forth up to 5. Like, for example, I'll just look at t is 1. When t is 1, minus 2t squared is negative 2. Plus 11t is actually 11, because it's 11 times 1. And then minus 12. And then when you sum these 3, minus 12 plus 11 is 9. 9 minus 12, you get minus 3. So that our completed table will now have these points. When t is 0, s is minus 12. 1, minus 3, 2, 2, 3, 3, up to 5, minus 7. We are going to plot these pairs of points on a Cartesian plane in order for us to draw our graph. And when we plot the points, like you see there, 0, minus 12, 1, minus 3. These are the points from our table. We plot the points and join our graph to form a parabola. The question is asking us to determine the values of t when s is 0. And this is the vertical s-axis, while this one is the horizontal t-axis. And s is equal to 0 on the horizontal t-axis. In other words, to determine the values of t when s is 0, we read where the graph meets the t-axis. And as you can see from the graph, it cuts the t-axis at that point, which is between 1 and 2, is 1,5. It also cuts at 4. So that part 3, the solution, therefore, from the graph, t is equal to 1,5 or 4 seconds when s is equal to 0. And if you look at these solutions, they are similar to the previous solution that we have determined. So this solution is a solution using the partial visualization method. Then the third method or approach is the visual symbolic thinking approach. And example 3, we are asked to solve that equation, which is the same equation. Now, I would like you to notice the difference between the visual symbolic thinking approach or symbolic visualization strategy and the analytic thinking approach in terms of how quick the solution is determined. So with this symbolic visualization approach, the solution is by factorization using visual symbolic thinking approach. We have our equation, we multiply throughout by a minus, make it positive. And then what happens here is that we look at the first term, 2x squared, and split it into 2 brackets to have 2x and x in the other bracket. And using this symbolic visualization in our mind, we look at the last term minus plus 12 and look for its 2 factors, which we are going to put in the 2 brackets in such a manner that the resulting product will give us the middle term. So that our next step will be, I think we're familiar with this because when we teach our learners this process, you take the 2x squared, you write 2x and x in the first and second bracket. Look at that, plus 12, the last term. Factors of that is minus 3 and minus 4. You know, when you are determining these factors, all this sifting and looking for the factors happens in your mind. So that's why we regard that as symbolic visualization. Because look, another person can say the factors of plus 12 is minus 6 and minus 2. But because you are using this symbolic thinking in your mind, you sift through all the pairs of factors and then find minus 3 and minus 4 be the appropriate factors that fit. Because what happens is you get 2x squared here, then minus 8x minus 3x. So this will be the factorization. And then when you equate each bracket to 0, you get x is equal to 1,5 over 4. So the symbolic visualization takes place between these 2 steps. And if you look at this solution, the number of steps that an individual goes through, we said the first one is not a step because it is the problem. So we have 1, 2, 3 steps. So in 3 steps, we managed to get our solution using the symbolic visualization. Whereas if you look at the analytic thinking approach, we had 5 steps, which was longer. That is where the difference lies, in that the symbolic visualization thinking approach shortens the process of determining the solution to a problem. And it actually shortens it and makes it an accurate approach in that an individual will quickly determine the solution, and that will increase the confidence in the solving of mathematical problems. This brings to an end my presentation. What I would like to point out as a recap is the fact that three methods that we used in the examples that we looked at in the video presentation were analytic thinking methods, spatial visualization thinking method, and symbolic visualization thinking method. And there are three methods all in all. And this visualization and symbolization teaching approach applies all the three, depending on what type of question an individual is looking at. So in other words, all the three methods of determining a solution belong to this approach. So that's why I indicated there that it is a multi-dimensional approach. It utilizes all the three components, actually four, if you know, you saw that flow diagram, and which makes this approach more diversified in that any problem that you encounter in mathematics education, you can easily solve it using this approach. And then lastly, I would like to point out to you guys that when we are applying these teaching approaches in our classroom, we don't normally tell our students which type of strategy or teaching strategy you are using to teach them a particular topic. Because the reason being, we don't want to overload our students with mathematical concepts that are extra and unnecessary. What we only know as teachers is the method that we are applying is kept to ourselves, but it will be a method that we actually understand that it helps our students to understand the subject. So we don't really tell them which teaching strategy you are applying. And thank you so much for your time. And until we meet next time, and I would like you to go and consider now how you are going to strategize and apply this strategy when you are teaching the two topics earmarked for this research. And I'll be visiting different teachers according to our schedule to actually conduct some observations on how you are finding the approach, as well as to support you in instances where you are not clear about the approach. Thank you so much. Enjoy the rest of the day.